My name is Rika Antonova. I am a postdoc at Stanford University, and I will tell you about dynamic environments with deformable objects. That's in collaboration with KTH from Stockholm, Sweden. First, let's consider what is interesting about deformables. They have a large state space with potentially an infinite number of degrees of freedom, contrasted with just 6 degrees of freedom for rigid objects. And if we wanted to annotate that state fully, that would be pretty expensive. So we're interested in self-supervised and unsupervised methods. Even if we learned a low-dimensional embedding for the state, the challenging dynamics in it would remain, and occlusions and high deformability would make similar states look unfamiliar, so data efficiency of methods that are made for rigid objects, that can deteriorate quite significantly. So we're interested in leveraging expertise from different fields, like from computer vision, perceiving the state of deformables from images, from machine learning, using learning from high-dimensional data. Computer graphics and topology can bring in structured and interpretable representations, and robotics can bring in planning and control for manipulation. So we are contributing a set of fast, open source, and extensible environments so that researchers from various fields can use them. They are based on an open source physics engine called PyBullet. They are fast to run and visualize, and you can also run the training in headless mode and then later look at the visualizations in a TensorBoard. We've created a number of different tasks that I will describe here. These tasks use OpenAI Gym interface. They're integrated with RL libraries, and they use a simplified grasping and control interface for those users who don't have background in robotics. And they're also easily customizable so that you can tune material properties and you can load your custom meshes, and you can use these environments and these tasks to create your own variations of them. So here is an example of hang bag task where we've provided a number of different meshes with slight variations, and despite visually initially how small the variation seems like, at the end you can see that the deformable shape changes quite significantly. Like here is another example with the apron where very similar trajectory and small variation in the mesh causes a pretty different behavior of the apron. Similarly here, trying to hang on a cardigan onto this hanger, we're executing here an identical trajectory, and with a small change in the mesh, you would see that one of the cardigans would end up hanged and the other one slips off. We've provided an example of how to import a very large number of meshes. So this is 22,000 garment meshes from sewing patterns dataset. So this demonstrates that you can basically create environments like our sewing V0 environment that samples from thousands and thousands of randomly loaded meshes and textures. And for even more training data, one can procedurally generate meshes here with 1 or 2 holes. And this is to anticipate the buttoning task, where the goal is to align the holes with the buttons. And you can see here with the gray cloth that's procedurally generated, that is still pretty challenging. The hole that is on the bottom slips off. And another set of tasks here is to dress a mannequin. Here's a highly relevant task of putting on a mask. And here is a task of putting on a backpack or a cardigan, and this is an example of a multi-stage long horizon task. Here we're demonstrating a preset hard-coded trajectory, and it would be wonderful if the various methods could learn this automatically, like reinforcement learning, for example. However, when we test currently available reinforcement learning methods, even with extensive hyperparameter search, we can see here that, for example, hanging an apron is not such an easy task. Same here with a different method, TD3 as opposed to PPO. Bringing in the bag close to the hook is easy, but then actually hanging it is pretty challenging. And similarly, you can see with other tasks, the initial progress is good, but then the final result maybe needs improvement. We have also provided a set of experimental environments for those who are interested in experimenting with robotics setups, for example, dual arm task here with Francos, and tasks with food packing where you can load YCB objects and pack them into a small amount of space, with the objective being to not squish the fruit very much, which is the deformable here. We have a set of documentation which shows the users the overview of our architecture, the user-facing parts, which is ability to train variational autoencoders or interface with reinforcement learning libraries or load preset trajectories. And we also have a README for you to get started quickly with using these environments, and we hope that you find all of this useful. Thank you.